Hey everyone, thanks for tuning in. Today we're going to be looking at how to solve trig equations, and we're going to be looking at some harder problems. Okay, so we're going to be applying some trigonometric identities as well as a bit of factorization rather. This is the final video of a three-part series. I highly suggest that you take a look at my previous two videos if you have not seen them, because the process I'm going to be using for this mimics the process I've used there, and I won't be explaining how I've actually done that. So yeah, with that being said, let's get into it. So the first question that we'll be looking today, and we'll be looking at three questions today, is to solve this. All right. So sine x plus root 3 cos x equals 0, and we need to solve it for the domain from 0 to 360 degrees. Okay. Typically, we've just seen sine x on its own, or like a cos x or a tan x just by itself, okay? And really, that's kind of the only way you can really solve these. So, obviously, we can see we've got two of them here, and that's stopping us from writing this as an equation in terms of just one function. So what we're going to do is we're going to subtract root 3 cos x, okay? And we get sine x is negative root 3 cos x. And then what I'm going to be doing is I'm going to divide by cos x. So I'll get sine x over cos x is equal to negative root 3. And we should know that sine x over cos x is going to equal tan x by the trigonometric identity, okay? If you're unfamiliar with this, I highly suggest you take a look at my video on the trigonometric identities, okay? But we should be knowing this if we're doing, if we're up to, solving trig equations, we should be confident in these trig identities. And now once we've gotten tan x equals negative root 3, now it's pretty simple. So now we find our reference angle, which is inverse tan of positive root 3, okay? And that's going to be equal to 60 degrees. Let the marker know that's our reference angle. And then make a little statement by saying that, tan x is less than 0 because it's negative root 3 in the second and fourth quadrant. Therefore, x is going to be equal to, now in the second quadrant, it's 180 minus theta, so 180 degrees minus 60. In the fourth quadrant, it's 360 minus theta, so it's 360 degrees minus 60 degrees. And we get two solutions, namely 120 degrees and 300 degrees, okay? So that's the first question, okay? I think it's important just to note that whenever we had, these two trig functions, trig equations here, our goal is to try and make it into one, okay? So, the next question we look at is something like this, okay? So solve 2 sine x cos x equals sine x for 0 to 360, okay? And a common mistake that students make is to divide by sine x and then say that 2 cos x equals 1, and then go cos x equals a half, and then you go from there. Now this is incorrect, okay? And the reason why is because when you divide by sine x in this case, we're eliminating this sine x, okay? Which in turn eliminates solutions, all right? It's for the same reason why x squared equals x. You can't divide by x here. So if we do, then we get x equals 1, but we're missing the solution that x equals 0. So what are we supposed to do in like this example over here? Well, we're supposed to subtract by x and get x squared minus x equals 0. We're supposed to factorize to get that. And then we get that x equals 0 or x equals 1. Okay? So we get two solutions, and we see because we divided by x, we eliminated a solution. Okay? So here it's for that same reasoning why we can't divide by sine x, because we eliminate this sine x, hence eliminating solutions. So what do? Well, same thing we did here. We subtract sine x, okay? So here I'm actually beginning it. So we go 2 sine x cos x, and we subtract sine x. So minus sine x equals 0. And from here we factorize sine x out of both of these, and we're left with sine x outside of, so factor sine x from this, and we're left with 2 cos x, and factor sine x from this, and we're left with negative 1, and that's equal to 0. And then we've got sine x equals 0, and we've also got 2 cos x minus 1 equals 0, okay? And from this we can just conclude that cos x equals a half. And now from here we've just got two separate trig equations that we need to solve for the domain from 0 to 360 degrees. So from here on, let's deal with the sine x is 0. So we got x is equal to inverse sine of 0, which is going to be 0 degrees, and that's our reference angle. Okay. So that means, well, because it's 0, it basically, kind of exists in all of the quadrants. So we say x is 0 degrees. It'll end up working out to be 0 degrees, 180 degrees, and 360 degrees. And the reason being is because it could be 0 degrees if it's in the first quadrant. If it's in the second quadrant, it's 180 minus theta, which is 180 minus 0. If it's in the third quadrant, it's 180 plus, so 180 degrees plus 0. That's supposed to be 0. And if it's in the fourth, it's 360 minus. Okay. And that leaves us with 0 degrees, 180 degrees, 180 degrees, and 360 degrees. And we've kind of doubled up on a 180. So we just say it's 0 degrees, 180 degrees, and 360 degrees. Okay, but that's one half of like the solutions. That's for like the sine x equals 0 branch. Okay, so these solutions over here correspond to that equation. So now we're going to be dealing with this equation over here, namely the cos x equals a half. Okay, so I'm going to deal with that over here. So same thing, x is equal to inverse cos of 1/2, and that's equal to 60 degrees, and that's our reference angle. And then we say, but cos x is greater than 0 in the, so where's cos x greater than 0? And that's the first and fourth quadrant. And then we, do the same routine. Therefore, x is equal to 60 degrees for the first quadrant, and for the third quadrant, it's 360 degrees minus theta, which is minus 60. And that gets us with 60 degrees and 300 degrees. So, now we finally conclude, therefore, alright, x is equal to, in ascending order, 0 degrees, 60 degrees, 180 degrees, 300 degrees, and 360 degrees. Okay, so they're all our solutions within the domain from 0 to 360. Okay, I hope this does make sense. Now the third and final question we're looking at is going to be something like this. Alright, so solve for 3 cos squared theta plus 5 cos theta equals 2 from 0 to 360 degrees. And the basic way to do this is recognize that it's going to be a quadratic. Okay, and so in doing so, we're going to subtract 2. So 3 cos squared theta plus 5 cos theta minus 2 equals 0. And now if we let x be cos theta, what you can hopefully notice is that it's going to be 3x squared plus 5x minus 2. So that's exactly what I'm going to write. 3x squared plus 5x minus 2 is equal to 0. And how do I normally solve an equation like this? And it's usually coming through factorizing. Okay, so if we factorize this, we're going to get 3x x equals 0, and we're going to have a plus 2 minus 1 Yep, that's correct. And then by solving this, we just get x equals a third, and x is equal to -2. Alright? But what did we say x was? Well, we said x was equal to cos theta. Okay? So now we get cos theta is equal to 1 on 3. Alright? And, I'll just focus that. And we get cos theta is equal to -2. Alright? And from here, we kind of just solve both parts of the equation. Alright? So let's start with this one. Cos theta equals a third. So we start with our reference angle, which is going to be inverse cos of a third, which is equal to, now this isn't an exact value. As a matter of fact, if we put it in our calculator, it's going to give us 70.53 degrees, and that's to our 2 decimal places. Alright, and that's going to be our reference angle. Reference angle. Okay, that's going to be our reference angle. And then it's kind of just the same process. So cos theta, but cos theta is greater than 0 or is positive in the first and fourth quadrant. Therefore, theta is equal to 70.53 degrees, because that's for the first quadrant. And then for the fourth quadrant, it's going to be 360 minus theta, so 360 degrees minus 70.53 degrees. That's equal to 70.53 degrees. And now 360 minus this gives us 289.47 degrees. Okay? So, yeah, that's what we get for one half of the solution. And now the other half is to solve for cos theta is equal to -2. Alright? And to find the reference angle for this, we're going to say that theta is equal to inverse cos of +2. And if we plug that into our calculator, that actually gives us a math error. Okay? So that basically means that there's no solution for theta which gives us inverse cos of 2. Now why is this? And so the reason why is because think about what how we define these functions, sine, cos, and tan, and it all came from right-angled triangles. Okay, and let's say we had a theta here. Okay, now we're saying, if we go back, we're saying essentially cos theta is equal to 2, which I can express as 2 over 1. All right. And remember, by SOHCAHTOA, cos theta is adjacent over hypotenuse. So 2 is my adjacent side. Alright, 2 is the side adjacent, and 1 is the hypotenuse. Okay? And the basic rule of right-angled triangles is that the hypotenuse always must be the largest side. Okay? Out of all three sides, the hypotenuse must be the biggest. And as we can see, well, 1 is obviously less than 2, so really, this is actually not even a right-angled triangle, because if we actually try to construct this, we have a base of 2, and we're supposed to have like a hypotenuse of 1, and so that's going to be about half the length, so let's say about there. And if we wanted to make a triangle, we'd have to connect it like this, and as we can see, none of the angles are right angles, so therefore it's not a right-angled triangle, hence why we get math error, and hence why there's no solution of theta which satisfies this condition. So what does this mean for the overall question? It just means that our solutions, to put it simply, were just 70.53 degrees and 289.47 degrees, because the solutions for theta didn't satisfy this half, but they did satisfy this one. Okay, so that means these are our only solutions over here. So I'll highlight them in blue. All right. So there's our solutions. Okay, so that is the basic process of how to do these trig equations. I hope you watched all 3 videos, because I did take you through basically every kind of question you could really see for these questions. So this was delving more into like some harder examples. Video 2 was detailing in how to change the domain, and video 1 was just the real basics of it all. So I hope you have learned something new. I hope these videos have helped. Yeah, good luck in your studies, and I'll leave you with that. Enjoy.